Hello everyone, and welcome back to the math. So in this video, we are going to talk about how to find the turning point of a quadratic equation. If you haven't watched the previous videos regarding quadratics, I'll leave a link in the top right. So let's try to get on with it. Like I explained before, in this section, we will learn how to find the turning point or the stationary point of a quadratic function. I will also try to add some real-life problems regarding this topic. We know that there are two types of parabola, the green one and the red one. For the green one, we know that it will have a minimum point, and for the red one, we know that it will have a maximum point. And as we know before, we know that the quadratic function will be y equals to ax squared plus bx plus c. And how do we know whether the parabola will be a red one or a green one? It depends on the value of a. So if a is positive, we know that it will be the green one. And it is shaped like a smile face. It is shaped like a smiley face. So therefore, happy means positive. On the opposite, if a is negative, we know the parabola should be a red one because this resembles a sad face. So sad means negative. We also know other types of quadratic functions. So y equals to d times x plus h squared plus k. This is in the form if we try to complete the square. Now, again, how do we know whether the parabola can be a red one or a green one? If d is positive, we know it's going to look like a happy face. So happy means positive. And if d is negative, we know it will look like a sad face. So sad means negative. So now we know that a parabola will have either a minimum point or a maximum point. These 2 points can also be called a vertex or a turning point or stationary point. Let's try to take a look at the first example. So the first step that we need to do is to complete the square. If we try to complete the square, we know that it will look like this. 2 times x minus 2 squared minus 20. And now, let's try to find the y values for x values near x equals to 2. So I have a table over here. We have the x and we also have the y values. The x that I will be using is going to range from 5 to minus 1. And now, let's try to focus if x is equal to 5. So if I try to input the x equals to 5, I know that I will get y equals to negative 2. If I try to continue this, let's say that x is equal to 4, I will get y equals to minus 12. If x is equal to 3, it will be minus 18. If x equals to 2, it will be minus 20. Now, here's where things gets more interesting. So if x is equal to 1, we know that it's going to be minus 18. If x is 0, it's going to be minus 12. If x is minus 1, it's going to be minus 2. So as you can see, the y value first decreases and then it increases again. And we know that the smallest y value that is possible is minus 20. And it is achieved when x is equal to 2. So now we know that the turning point of this quadratic function is 2 comma minus 20. And as you can see in the formula, we know that the turning point will be in the formula of minus h comma k. Now, how do we know whether this turning point is a maximum point or a minimum point? We just have to see the d value. So we know that the d is positive in this case, so it should be a minimum point or a minimum value. On to the next example. So again, we need to complete the square and we have this form. Y equals to minus x plus 1 squared plus 2. And now, let's try to find the y values for x values near x equals to minus 1. So I have the same table, a similar table, and the x that I will be using is from 2 to minus 4. So if x is equal to 2, I can try to input the x value and I will get that y is equal to negative 7. If x is equal to 1, I will have minus 2. If x is 0, it will be 1. If x is minus 1, it will be 2. And now, if x is equal to negative 2, we know that the y should go back to 1. If x is minus 3, it will go back to minus 2. If x is minus 4, it will go back to minus 7. As you can see, the y value starts to increase and then it decreases back. And we know that the highest or the maximum value of y that we can get is 2, and we can achieve that if x is equal to minus 1. So the turning point in this case is -1, 2. And again, we can try to use the formula -h, k. And now, how do we know that this is a minimum point or a maximum point? Again, we can try to see the d value. So the d will be less than 0, and it will have a maximum point. Okay, so we have seen how to find the turning point if we try to complete the square first. But what is the direct formula if we don't want to complete the square? So I will try to derive the formula to find the turning point. Again, if you feel that you're not really interested in the derivation, or if you feel that the derivation is a bit complicated, it's okay, you can try to skip it. But for those of you who want to see the derivation, let's try to get on with it. So the first step that we will do is we will take out a, so it's going to be a times x squared plus b over ax plus c over a. After this, we can try to complete the square. This one is going to be a bit complicated, but I will try to give you the final result. So it's going to look like this. After this, we will try to multiply a back into the bracket, and it's going to look like this expression. After this, we will try to simplify, so we will make the second term such that it has the same denominator. So it's going to look like this. The next step that we will do is we will combine the fractions since both of them have the same denominator now. After this, we will try to factor out -1 from the fraction. So it's going to be minus bracket b squared minus 4ac over 4a, and then we will put the minus sign in the denominator. So the end result, the formula, is going to be a times x plus b over 2a squared plus b squared minus 4ac over minus 4a. Now, this might look complicated and this might feel overwhelming, but don't worry, you don't have to memorize the whole thing. I will try to summarize everything that you need to know. Okay, for those of you who skipped the derivations, so this is the summary that I made. There are two ways to find the coordinate of the turning point. The first one is if you try to complete the square. If you try to complete the square, the quadratic equation or the quadratic function should be in the form of y equals to d times x plus h squared plus k, and the turning point is going to be -h, k. This is the first method. The second one is if you want to use the formula directly, so you don't have to complete the square, you can just use the direct formula. So you just need to find the a, the b, and the c. Again, you can choose whichever is more convenient. I usually prefer the first method since it's much more simpler, but you have to complete the square first. But again, it's up to you guys. I have also designed a flowchart so that it will make it easier for you to choose the method that you want. So every problem will start with this expression, y equals to ax squared plus bx plus c. And the first thing that you need to ask yourself is, are you good at memorizing things? If the answer is yes, you can use the formula directly, which is this formula. But if you're not good at memorizing, then you need an extra step because you need to complete the square, you need to change the form of the quadratic function, and then you can try to use this simple formula. Again, you can choose whichever method is at least easier. I know that both of them are hard. So now we will try to take a look on how we can try to plot the turning point in a Cartesian coordinates. So let's say that if I have this parabola, and I know that this is a smile face parabola, so we know that the d should be bigger than 0. We also know that the turning point for this type of expression is going to be -h, k, and -h, k is going to be the minimum point. And now we can try to see that the x, which is equal to -h, is going to be what we call the line of symmetry. So this line is actually the line of symmetry of the parabola. It divides the parabola into an equal figure. That is the line of symmetry. And then for the y value, we call it the extreme value. And again, the extreme value can be a minimum if the d is positive, and it can be a maximum if the d is negative, as we will see next. So now in this case, I will try to use another type of parabola shape. So we know that in this case, D should be negative since we will get a maximum point. And the turning point, again, it's going to be minus h comma k. And we know that x is equal to minus h, which is the line of symmetry. And the y equals to k is going to be what we call the extreme value. Now let's try to move over to the next type of quadratic function, which is ax squared plus bx plus c. Let's say that we have this type of parabola. And now we know that if the parabola is shaped like this, a should be positive, since we have a turning point, which is a minimum value. After this, we know that the turning point will have this formula. So if we try to plot it, it's going to look like this. And we know that x is equal to minus b over 2a. This is going to be the line of symmetry. Again, it will divide the parabola into a very identical shape. And the y value is what we call the extreme value. Now, let's say that I have this type of parabola. We know that a should be negative, and we will have a maximum point. And the coordinates of the turning point is going to look like this, and we can try to plot it. And then we know that x, again, it's going to be the line of symmetry, and the y is going to be the extreme value. Now, let's try to take a look at some examples. So in this problem, we want to find the turning point, the line of symmetry, and also we need to know whether the turning point is a minimum or a maximum point. In this case, we know that it's going to be in the form where we complete the square. So we can try to find the d, the h, and the k first. D is negative 1, h is minus 3, and k should be 12. After this, we can try to use the formula directly. So the turning point is going to be x equals to minus h or y equals to k. So the turning point is going to be 3, 12. After this, the line of symmetry is going to be x equals to 3, and the type of turning point, since we know that d is negative, is going to be a maximum point. Now in this next problem, we know that the quadratic function is in the form of ax squared plus bx plus c, and we can still try to find the turning point, line of symmetry, and decide whether the turning point is a minimum or a maximum, okay? So again, we can try to first find the a, the b, and the c. After this, we can try to find the turning point by inputting the formula. So we will try to input the a, the b, and the c, and beware of the negative or positive sign if there are any. So after calculations, we know that x should be minus 3 over 2 and y should be minus 25 over 2. After this is the turning point. Again, be careful of the minus sign when multiplying or dividing. The next thing is going to be the equation for the line of symmetry, and we know this is going to be the x value. So x is minus 3 over 2, and the type of turning point, since this is a positive a value, then the turning point will be a minimum point. So in this next example, it's going to be very similar. Again, we have to find the a, the b, and the c, and then we can try to input the ABC values into the formula for the turning point. And we get that x is equal to 5 over 2 and y should be 21 over 4. So x comma y is 5 over 2 comma 21 over 4. Again, be careful of the minus sign when we are doing the operation. After this, we can try to find the line of symmetry, and it's going to be the x value. So the line of symmetry is going to be x equals to 5 over 2, and for the type of the turning point, since we know that a is negative, it will be a maximum point. In this next example, we are going to see how we can try to utilize the formula for turning point into a word problem. So a company estimates that its profit from selling a product can be modeled as the following quadratic function, where x is the amount of goods sold. What is the maximum profit that can be achieved, and how many goods should be sold in order to achieve that? So we know that Px is the profit and x is the amount of goods sold. And for this, we will try to find the ABC values, as you can see. And after that, we can try to find the maximum profit. So the maximum profit is going to be the y value, the extreme value in this case. So we will try to find for Px, and we will try to use the formula for the y. So we can try to input the ABC, and we get that the maximum profit is going to be $150,000. Remember that the profit formula is in thousands of dollars, okay? After this, we can try to find the number of goods to achieve maximum profit. And the number of goods is going to be the x, so we can try to input the x formula and we get that x should be 10. So in conclusion, the maximum profit is $150,000 and the company needs to sell 10 goods to achieve it. Now, the next example is going to be another word problems. A car engineer estimates that the fuel consumption in liters per kilometer at a speed of x kilometers per hour can be modeled as this quadratic function. At what speed is fuel consumption minimized and what is the corresponding fuel consumption? So in this case, we know that fx is going to be the fuel consumption and x is the speed. And we can try to find the ABC. After this, we can try to calculate the speed, so the x value, right? So the x should be minus b over 2a, and if we try to input the values, we know that x is equal to 60. So we know that at 60 kilometers per hour, the fuel consumption will be minimized. Now, what is the corresponding fuel consumption? We can try to calculate that with the formula we learned before. So since fuel consumption is the y value in this case, we can try to use the y formula for this. And again, we can try to input the ABC values. We get that f of x minimum is 9. In conclusion, we know that the fuel consumption will be minimized at 60 kilometers per hour. And at that speed, the fuel consumption will be 9 liters per kilometer. Okay, so that's how we use this material to answer word problems. So these are the exercises that I've prepared. I hope that you can try to do it so that you can be more familiar with the method that I've taught just now. Okay, so that's it for this video. In this video, we learned how to find the turning point of a quadratic function. What do you think about this video? Please leave a comment and don't forget to leave a like and subscribe. I'll see you on the next video. Thank you.